When we multiply fractions, we multiply straight across. So this is 80x to the fourth times x. Well, so that would be 80x to the what? Fifth. So 80x to the fifth, and then times y on top. And on the bottom, we just have 5x squared y to the third. Okay. Now we need to simplify that. We can reduce now because we can cancel out factors, right? There's nothing added or subtracted that's preventing us from being able to cancel out these x's and y's or reduce these x's and y's. And so the 80 and the 5, that's just regular whole numbers. So we reduce those like we would reduce any fraction. Divide them both by 5. So 5 divided by 5 is 1. 80 divided by 5 is what? 16. Okay? And then we have x to the fifth and x squared. And when we divide those, what do we get? X to the third. And does it go on top or bottom? On top. X to the third. Okay? Now, and then this is y to the first power over y to the third. So when we reduce those, we get y to the second. And does it go on top or bottom? It goes on the bottom. So what I have left is 16x to the third over y squared. Yes?
How do you know if the y or the x is 1?
Okay, so this is like x to the fifth over x squared, right? X to the fifth is x times x times x times x times x. You agree? Right? That's x to the fifth. And x squared is x times x, right? So if you cancel these out, you're left with x to the third on top. Okay? So you subtract those exponents, and wherever the higher exponent is, that's where the answer goes, because that's where the leftovers would be. Okay? Okay, for number 2, we need to factor this stuff. All right? And so x minus 3 can't be factored. It's already factored. I can factor my greatest common factor out of here, so it's 2 times x minus 4, right? Times. I can factor my greatest common factor out of here, so it's 6 times x squared minus
16.
Thank you, 16. But what is this?
That's a
Difference of squares. That's the difference of squares, so that can be factored further. So that's 6 times x plus 4 times x minus 4. So that's fully factored. Now the bottom, what's this? Difference of squares. So that's x plus 3 times x minus 3. So now we have all factors. All things times each other. So now we can cancel out those things that are multiplied times each other. Okay? And so when we multiply fractions, we multiply straight across. So do you agree this is like one big fraction? Okay? And so now I can cancel out. I always start with the top, and I always start with the top left, like you read from left to right. And I say, do I have another x minus 3?
Yes.
Yes, those cancel. Can I reduce this 6? Yes, I can with this 2. Okay? So if I divide them both by 2, that becomes a 3. Do I have another x plus 4 on the bottom? No. Do I have an x minus 4? Yes. So what is left on top is 3 times x minus 4 over x plus 3.
Wait, how come?
Huh? Oh, thank you. Plus 4. Sorry about that. Was that the question? Okay.
I just think I got it.
Okay. Any questions on 1 or 2? Any more questions on 1 or 2? Okay, let's move on. Number 3. Okay, so you can either factor and then flip, or you can flip and then factor. Okay, it's up to you. I'm going to factor everything first, just because it uses less lead. And so this, that's a trinomial. How do I factor that? AC method. Why can't I cancel this x squared with that x squared? Because it's not a factor. It's not a factor. It's part of a term. Okay, it's part of all this. Remember how I proved to you yesterday that you can't do that mathematically? Yeah. Okay, it's not equivalent. It's not equal. And so we need to factor this. This will become, if it can be factored, will become that once we figure out what it is. And this down here will become that once we figure out what it is. Okay? These two can't be factored anymore. All right? So now I'm going to take 3x squared plus x minus 2, and off to the side, I'm going to go do my AC method so I can figure out what goes in here. Okay? And so I multiply a times c. So 3 times negative 2 is negative 6. Whenever what is my factors that multiply to equal negative 6, but add to equal positive 1? It's going to be 3 and 2, and the 2 has to be negative, right? Okay, and so now I would take this 3x squared plus x minus 2, and I will change the plus x to plus 3x minus 2x, and then minus 2. We expanded that middle term, remember? The AC method? Yes? Okay, so now we're going to group. So take out a 3x, leaves me with x plus 1. Here I take out a negative 2, leaves me with x plus 1. So that's 3x minus 2 times x plus 1. Okay, so that's what goes up here. 3x minus 2 times x plus 1. Yeah? That was our AC method that we did factored on the top. Okay? So now I need to do the AC method down here, but it's the easy one because I don't have a coefficient of 1. So we don't have to worry about the grouping. So my factors that multiply to equal 2, but combine to equal 3, you only have one option, and that's 2 and 1, right? So that's x plus 2, x plus 1. Okay? So I've factored everything I can factor. Since this is division, I have to flip this second one. So let's do that now. So now I have 3x minus 2 times x plus 1 over x plus 2 times x plus 1. Instead of division, it's multiply times x plus 2 over 2x. I've factored, I've flipped, now I can start canceling. So this is like one big fraction, okay? So do I have another 3x minus 2 on the bottom? No. Do I have an x plus 1? Yes. Yes. Do I have an x plus 2? Yes. Yes. And I'm done. So what I'm left with is 3x minus 2 over 2x.
Good job.
Any questions? Any questions? As long as you can factor, it's not hard. Okay, for number 4, I don't have anything to factor, so I just need to flip what's after the division sign. So that puts me at 2xyz over x squared z squared times 3xz over 6y to the third. Okay? Now I need to simplify that numerator and that denominator before I start trying to cancel things out. Okay? So I multiply my whole numbers. 2 times 3 is 6. X times x is x squared. We don't have another y. And z times z is z squared. I don't have anything to multiply 6 by, so I just put 6, x squared, y to the third, and then z squared. Okay, so my numerator is simplified and my denominator is simplified. And so now I need to start reducing slash canceling, which is sometimes the same thing. Okay? Well, 6 divided by 6 is 1, so it cancels. X squared divided by x squared is 1, so it cancels. Okay. Okay, I have y to the 1 and y to the third. What does that equal? Y squared. Top or bottom? Top or bottom? Bottom. So this becomes y squared. And then z squared over z squared cancels. Now, I don't have anything left on top. Does that mean 0 on top? No. What does that mean? It's 1. 1 over y squared. That's all that's left. Okay, number 5. I do see things that I can factor, So I'm going to factor before I flip. So here I can factor out a 2x. And when I do that, it leaves me with x minus 6. Okay, here, how am I going to factor this? AC method. That's the easy one, right? So I know it's going to be x and x, all right? So 6 and 1, but what do their signs have to be? Both negative. So that's minus 6 minus 1.
Oh my god.
Okay? Here I can factor out a 3. So that leaves me with x minus 1. Okay. Am I done factoring?
Yes.
Yes. So what do I do next?
Now you have to undo.
Now I have to flip, right? I factored. Now I need to flip and rewrite it all. So I have 2x times x minus 6 on top, and then I have x minus 6 times x minus 1 on bottom, and that changes to multiplication. So 3 times x minus 1 over 2x. I factored. Now I flipped. Now I need to simplify, right? This is like one big fraction now. Okay? And so, start with the top left. Do I have another 2? Do I have another x? Do I have an x minus 6? Do I have a 3? No. Do I have an x minus 1? So, the only thing that's left is 3. You could say 3 over 1, but that's just 3. Okay? Okay. So yesterday, we multiplied and divided fractions.
Yes.
Today, we're going to add and subtract. When you add and subtract fractions, you have to have a common denominator. If your denominator is the same, for example, if we had 2 over 5 plus 1 over 5, since the denominators are the same, you can add the tops, right? So that's 2 plus 1 over your common denominator. You just write your denominator once, right? Okay? And then you simplify this, and that's 3 over 5. Okay? Well, the reason why I showed you this step right here, where you write the 2 plus 1 over your denominators, because when there's variables involved, you can't always just combine those terms. So you just write them on top and put it over your denominator. So when we're looking at this first example, my denominators are already the same. Now remember, they have to be exactly the same. If they're not exactly the same, we're going to have to do what we're going to need to do on the next slide. But they have to be exactly the same. Once they are exactly the same, we can do just like we did up here, where you add the tops, combine the tops. Now remember, there's a plus in between here. If there was a minus in between here, then we would assign that negative to the numerator on the next fraction. But we'll look at that in a minute. But I want you to pay attention to this. Because this is a plus, it doesn't affect these. So we have a plus 3b plus a minus b all over our denominator, which is 15a. Just like up here, we just wrote our denominator once. We do the same thing down here. Okay? And so now, all you have left to do is simplify the top. All you have left to do is simplify the top, which means combine your like terms. Sometimes you may end up having to distribute it before you can combine your like terms. Okay? So, we have a plus a, which is 2a. We have 3b minus b, which is 2b. And all of that is over 15a. Okay. Combine my like terms on top.
So you want the x minus 1 when you multiply? Yeah.
Wait, what?
The x minus like a squared.
No, because we're adding. We're not multiplying. When you're combining like terms, you're either adding or subtracting. It's like saying you have 4 apples and 3 apples. That gives you 7 apples. That's not 7 apples squared. It's just 7 apples. You're counting how many things you have. That's all. When you're combining like terms, that's all you're doing. When you're multiplying, those things change. Okay. And so now we have 2a plus 2b. What you want to do now is you want to factor that top, because you want to see if it's possible to simplify it with anything at the bottom. Okay? In this case, it's not going to, but you always want to do that. You always want to check and make sure. So I'm going to factor my greatest common factor out of here, which is a 2. So times a plus b over 15a. Now, I didn't have anything that I could cancel or reduce. Can I cancel that A with that A? No. This is not a standalone factor. Okay? If it was 2A times this, yes, then I could cancel it with that A. But I can't the way it is right now because it's included in another factor. All right? And so this is my answer. So once your denominators are the same, you just combine the top, simplify it, factor it to see if it can cancel with anything at the bottom, and you're done.
What if I didn't do that? Like, what if I left
If you left it like that, it would not be completely finished. It's not simplified. We're not solving, we're just simplifying.
Okay.
If we get the 2 and the A, like.
Okay, because we have 1A here and 1A here, so when you combine those, you get 2A.
No, I mean like.
Right here, I factored out my greatest common factor, which is 2. Okay? Any other questions? Y'all do the second one.
Your turn.
Your turn. Okay, my denominators are the same, so I know it's going to be over 20x squared y, right? That's my denominator, my common denominator. Common means they both have the same thing. And so I just combine my tops, 4x plus x plus 6y over that. So I just need to simplify that numerator. So 4x plus x is 5x plus 6y over my denominator, 20x squared y. Now, I don't have a greatest common factor I can factor out of here, so I'm done. That's as simplified as I can get it. Don't make the mistake of trying to cancel that 5 with that 20. It can't. It's not a standalone factor. All right? And so this is it.
How do you know when it's a standalone factor?
If it's that times, they're separate factors. Like if it was 5 times x plus 6y over 20x squared y, then you could do that because this is a standalone factor. You can only cancel factors. If it's a term that's part of another factor, it's not legal to do that. Okay? Yesterday, Devin wasn't here, so yesterday I'll show real quick. This is why you can't do that mathematically. Say we had 2 times 3 over 2 times 4. Okay? 2 times 3 is 6, and 2 times 4 is 8, right? So that reduces to 3/4, right? So you could cancel these, and it equals 3/4, right? So that's why we can cancel these factors, okay? But if you had 2 plus 3 over 2 plus 4, 2 plus 3 is 5, and 2 plus 4 is 6, right? This is what it, mathematically, this is correct. This is what it equals. If you cancel these 2's, that's 3/4. That is not equal to 5/6. So you can't cancel things that are added to something else. You can only cancel things that are multiplied because you can reduce it at the end and divide by that and get back where you started. Does that make sense? Okay. So that's the reason why you can't cancel part of terms. Okay. Any other questions? All right. Now let's look at some where the denominators are not the same. Let's look at some where the denominators are not the same. Now, we cannot combine those tops until the denominators are the same, right? Okay. So, back to regular old fractions. So, let's say we had 2/3 plus 1/4. How do we find a common denominator? Well, you could multiply 3 and 4, but you say, what's the biggest number? No, actually, what's the smallest number that both of those can go into evenly? You don't want the biggest number. That would be a humongous factor. So basically, you look at the multiples of each and you figure out what's the smallest one that I can divide both of them into. We know it's going to be 12, right? And then we have to force both of those denominators to turn into 12. Okay? So what you would do is we would multiply this by 4, right? And then we multiply that by 3, right? That's how we make those be 12. But if it's a fraction, in order for it to stay an equivalent fraction, what you do at the bottom, you have to do at the top, right? So if I multiply this by 4, I have to multiply that by 4. Then they stay equal. And so if I multiply this by 3, I have to multiply that by 3, right? So then that becomes 8 over 12 plus 3 over 12, which is 11 over 12. You can add those now, right? So those are our steps for finding a common denominator and forcing our denominators to be the same. We're going to do the exact same process here, okay? So the trickiest part is figuring out what you need to make both of those denominators be. And we're going to multiply by something to force them to be the same, okay? And so I have, look at your whole numbers, I have 6 and 5. What's my common denominator going to be between 6 and 5? 30. 30 is the smallest one that they can both divide into, right? Well, sometimes you don't want to do that because it'll give you a factor that's way too big, but you could, but it's going to cause you to have to reduce more at the end.
What do you use whenever you like multiply to get the same denominator? You have to multiply top and bottom.
Absolutely, it has to stay the same. Okay, so we know that our common denominator, I'm going to put it up here, our common denominator is going to be 30, right? But it can't just be 30, we have variables too. Okay, we have variables too. We need those to be the same. We need to force those to be the same. So when you look at your variables, if it's common, that means both of them have to have it, right? And they both have to have the same thing. So I can make both of them, let's look at the x first, so let's go in alphabetical order. I have an x to the third here, so what would I need here? I need an x to the third, right? And then I have a y here, so what would I need here? A y. So I can make both of them be 30x to the third y. So let's make this one turn into 30x to the third y. And so what I'll do is I'll multiply this by 5. And what else did I need? X to the third. Now, once I multiply this, it's going to be 30x to the third y, right? But if I multiply the bottom by 5x to the third, I have to multiply the top by 5x to the third. Okay? And so now let's force this one to be 30x to the third y. So I have to multiply it by 6y. Now that'll be 30x to the third y, right? But if I multiply the bottom by 6y, gotta do it to the top. Okay? So now our next step was let's actually multiply them and see what we have, okay? And so now, 5x to the third times 6 is 30x to the third, and that's over 30x to the third y, plus 4 times 6 is 24xy over 30x to the third y. Now, don't make the mistake of going, oh, I can reduce this, because you're going to end up back here, okay? If you take this and try to simplify this piece right here, you're going to end up right back here where you started. So don't do that.
That's not what we want.
That's undoing what you just did.
You can't add the top because.
Yes, I can.
they're
Sure I can.
different variables.
It doesn't matter. I'm going to put 30x to the third plus 24xy over my denominator, which is 30x to the third y.
How would you have?
Now, let's take our greatest common factor out of the top. We didn't have any like terms that we could combine, but we can factor out a greatest common factor. Okay? So, my greatest common factor is 6x. That's it, 6x. So, once I take a 6x out, I end up with 5x squared plus 4y over 30x to the third y. And I factored that I factored this top because now I can simplify this, because these are standalone factors. 6 times x times that, right? So 6 and 30, 6 and 30, I can reduce. I can divide them both by 6, and I get 5 down here. And then x and x to the third is what?
X squared.
Top or bottom?
Five.
Because that's where the leftovers would be. You have x on top, you have only 1 on top, and you have 3 on bottom. So if you cancel one of those, you have 2 left on bottom. Okay? And so now, all we have left to do is write our final answer. So our final answer is 5x squared plus 4y over 5x squared y. Can I cancel that 5x squared with that 5x squared? No. It's attached.
Well, you say this is what
It's more sense.
it's easy.
If you think about it in terms of how do I add regular fractions, those steps apply to this as well. Okay? You have to get a common denominator. The way that you force those denominators to be the same is by multiplying it by something. But what you do on the bottom, you have to do on the top too. And then you simplify, factor, and hopefully simplify some more. Right? Okay. All right. So, when I figure out my common denominator, my common denominator between 3 and 2 is going to be 6. Okay? And then what you basically do is you look at your variables, and for your variables, you want the highest exponent of those variables. And you have to include every variable in your common denominator, okay? And so I have an m here and an m squared here. We want the highest exponent, m squared. We have an n squared here, and we don't have one here, but you have to include everything, so n squared. So maybe that will help you to figure out that common denominator. Figure out your common denominator between your coefficients, your whole numbers, okay? And then for your variables, you have to include every variable, and you want the highest exponent out of what's there, okay? So now, I need to make both denominators be 6m squared n squared. So over here, I need a 2, and then I have an m, I need another m, and I already have n squared, right? And over here, I need a 3. I already have an m squared. I need a n squared. What I do on the bottom, got to do on the top. So we have to multiply this by 2m also. And we have to multiply this by 3n squared also. You can't multiply something different on top because then you've changed that fraction. 2m divided by 2m is 1, right? Anything divided by itself is 1, right? So all I did was I took this fraction basically and I multiplied it by 1. So I didn't change the value of that fraction. That's why what you do on the bottom you have to do on the top. Okay? And so we're manipulating them is all we're doing. We're not changing them. We're just shifting things around. And so now what I have left on top is 6m over 6m squared n squared plus 12n to the third over 6m squared n squared.
Well, yes.
4 times 3, what are we?
Top. On the top, 6 times
12, that's what I
I'm like, what
mean.
you talking about?
12m, thank you. See, I just check y'all every now and then. Okay. And so now our denominators are the same. We need to combine the tops so that we only put it over one of the bottoms, and then we need to factor and simplify. Okay? So now we have 12m plus 12n to the third over our common denominator. And then you ask yourself, can I factor that top? Well, yes, I can. I can take out the GCF, which is 12. So m plus n to the third over 6m squared n squared. Okay? So now, Can I reduce or cancel anything?
Yes.
Can I cancel anything that's inside these parentheses? No. I would have to have m plus n to the third on bottom to be able to cancel that. All right? And so 6 and 12, I can divide both of those by 6, and that becomes a 2. Because technically this becomes a 1. But we don't need to write 1 times anything. And so now my answer is 2 times m plus n to the third all over m squared n squared. And you're done.
This is easier.
Okay. Copy these down. Same thing. Same thing. Okay. Now, this one, 6 is a standalone factor, right? K is a standalone factor, right? Is that a standalone factor? No. K is not multiplied to anything. That is together. That's together, right? That, K minus 1, is a standalone factor. Yes.
Just like legal, like
Wait. Shh.
if you, about the like the subtraction, you can turn it into addition, but then make the.
That is what we're going to do anytime you see a subtraction. You are going to change it to addition, and then you're going to multiply the numerator of the next fraction by -1. So in this one, I'm going to change it to addition, but can I just multiply the r by -1? No, because that is together. So it makes that whole factor negative. Do y'all see what I just did?
Yeah.
Okay. And so that's when it's subtraction, do that first before you start trying to do common denominator and all that, because it's easy to mess up those signs when you combine the tops if you don't do that. All right? And so now, when we're trying to find our common denominator, okay, my whole number is just 6, right? So 6. Now look at my variables, which are my factors. My first one is K. That has to be included. The other factor is K minus 1. That has to be included. Okay, so I need to make both denominators be 6K times K minus 1. Well, that's easy. We can do that. So let's start over here. I already have 6K. What am I missing? K minus 1. So what I do on the bottom,
You gotta do it.
I have to do it on the top. Okay? Now, on the right-hand side, what am I missing? 6 times K. So times 6K times 6K. Okay? So now, on top, I need to distribute this too. Okay? Well, on your tops, now when we have these factors that are expressions in the denominator, you want to leave it in factor form. You want to leave it in factor form because at the very end, you want to cancel things out with that if you can. But on the top, you need to distribute everything so that you can combine all your like terms. Okay? And if you mistakenly distribute everything on the bottom, that's fine. You're just going to have to refactor it again at the end. Okay, so I need to distribute this. Okay, so now well, let me not skip a step. We're not there yet. Okay, so on top I have 2K minus 2 over, I'm going to leave it 6K times K minus 1. Okay, I'm not going to distribute that on the bottom. And then I have plus, and then -4 times 6 is -24 over 6K times K minus 1. So that's my common denominator. Okay. Got it. Whew. Okay. Thank you. So, now our denominator is the same. It's just back to like a problem we were just doing. Okay? And so we're going to combine our tops. So that's 2K minus 2 and then minus 24K, because it's negative, over 6K times K minus 1. Right?
Right.
What now? Combine my like terms, because I have 2K minus 24K. That's a positive 2, that's a negative 24, negative 22K. So that's negative 22K minus 2 over 6K times K minus 1D. Are y'all seeing why I'm leaving this 6K times K minus 1 and I didn't distribute that? Okay, what am I going to have to do next on top? Factor out my greatest common factor and hope it cancels with something on the bottom. So if I would have distributed this stuff on the bottom, then I'd have two things I need to factor out my greatest common factor right now. You know what I'm saying?
Yeah.
Okay, so my greatest common factor up here is 2 or negative 2. So that's 11K plus 1 over 6K times K minus 1. Boy, it would be nice if these could cancel, but they can't. Okay,
You can sit down.
so I can simplify what?
Yeah.
The 2 and 6, right?
Yeah.
So I can simplify the 2 and 6. And if you would have taken out a positive 2 right here, it would just be negative 11K minus 1 on the inside. Your answer would vary a little bit from the answer we're going to get right now, but it would still be right. So 2 and 6, we can divide them both by 2. So you have negative 1 and 3. So all I have to do is write my final answer now. Okay? So that equals negative 11K plus 1 over 3K times K minus 1. And so if you had negative 11K minus 1 over that, that's correct also. Okay, so we found our greatest common denominator, our least common denominator. And we forced our denominators to be the same. And so I have to distribute this 12 times r plus 3. So this is 3 times 4, which is 12.
Oh, man, I was about to get up the line.
Okay? And so you get 12r plus 36. And then you distribute the negative r. So then you get negative r squared minus 5r.
Oh, okay.
And then you combine your like terms on top, and you get negative r squared plus 7r plus 36, and that can't be factored. The AC method will not work. You cannot find factors of 36 that combine to equal 7.
Okay.
So that's your answer.